This is Iceland, a place that offers a great opportunity to see exactly how Earth's inner heat is continually reshaping the planet's landscape. Molten rock usually lies hundreds of kilometres underground, but here, as in Ethiopia, it's much closer. Yet the effect is very different. Sulphurous fumes and bubbling hot pools hint at the power that is just beneath the surface. Just 20 kilometres beneath Iceland is a vast column of superheated rock, known as a plume. Recently, the shape of this hot plume of rock has been mapped. It's 100 kilometres wide and at least 600 kilometres deep. Created more than 50 million years ago, the plume is sustained by heat continually rising up from the Earth's hot core. But what makes Iceland so unusual is not just that it sits above a hot plume. This small island is also shaped by the Earth's inner heat in a way. From the air, you can begin to see just how unusual this rock face is. It's a crack in the Earth's surface that runs for hundreds of kilometres. But what we're looking at is just a tiny part of something much, much bigger. This is the edge of a gigantic slab of the Earth's crust which runs unbroken for 7,000 kilometres. Right from this point, under the Atlantic, across the USA, all the way to California. It's what's known as the North American Plate. The Earth's surface is broken up into 7 major chunks called plates. They're so enormous that they can carry an entire continent and extend far under the sea. Strip away the Atlantic Ocean and you can see a long boundary between 2 of these plates that runs along the ocean floor until it rises above the waves, cuts through Iceland, to eventually join up with the rock face at Thingvellir. It's hard to imagine a force that can move continents apart, yet this is precisely what the Earth's inner heat is able to do. It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move across the Earth's surface. To appreciate the idea of continents moving, you have to step outside human timescales and think in terms of a completely different time frame. The continents here are drifting apart at 2 centimetres every year. In my lifetime, we're talking just a couple of steps. Even in 1,000 years, that's just 20 metres. It's only when you start to think in terms of millions of years that you realise just what can happen. 225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent. We've seen what happens when the plates move apart. But when they crash into one another, the effects are even more dramatic. The collision of the Earth's plates is responsible for the most spectacular mountain ranges on our planet. To see how they're created, I've come to New Zealand's South Island. These stunning peaks run 500 kilometres along the west coast, forming a dramatic spine. What was to become New Zealand was once a group of scattered islands. The collision of the Pacific and Australian plates forced these islands together, creating the familiar outline of New Zealand that we know today. Along the collision zone, the land was buckled and a line of mountains rose up. New Zealand's mountains are around 5 million years old. That may sound ancient, but it's just a geological blink of an eye. Yet even in this short time scale, these peaks have grown into giants. All the world's great mountain ranges form in this way, when continents collide. You can really get a sense of how the surface of the Earth crumples when you look down from space. These are the European Alps, the South American Andes, and the Himalayas of Central Asia. They're all relatively young, born out of recent collisions between plates. But this is what happens when our planet builds its great mountain ranges. In October 2005, a devastating earthquake hit the western Himalayas in northern Pakistan. The area around the town of Muzaffarabad was completely razed to the ground. But satellites measuring the height of the surrounding land before and after the earthquake revealed that something else had happened as well. The red and yellow colours show how the hills to the east of the earthquake's epicentre had actually risen as much as 5 metres during the earthquake. This process, repeated thousands of times, has helped build the Himalayas into the greatest mountain range on Earth. And it's just as well that the Earth's inner heat continues to push mountains up.